Some of you might be asking, why is this plant tall while both of its parents are short and tall? For that, I will let my brother explain. Oh, thank you for that wonderful question, my beautiful, handsome, and something brother. Well, the answer for that is one allele dominates the other, which is explained by Gregor Mendel on his principle of dominance in Mendelian genetics. But we all know that's not what the title says. We're gonna talk about non-Mendelian genetics. Okay, the first part we're gonna talk about today is incomplete dominance. Well, incomplete dominance is instead of having a dominant allele become the dominant trait, it become in between of the two alleles. Oh, that's great! That will make the offspring unique from its parents. Shut up, James. Well, moving on. Incomplete dominance happens when a dominant allele is not completely expressed when a recessive allele is around. So, there's no clearly a dominant allele. For that, I will let my assistant give you one example. So, Elka, show them.
Thank you, Mr. Sid. So I will be using the Punnett square to explain it properly. The Punnett square is the usual diagram explaining the possible offsprings between a male and female organism.
So we will be having two examples. One is the blue flower, which will be represented by capital R and capital R, and yellow flower, which will be represented by lowercase r and lowercase r. So if we use the Punnett square to combine the two, the results would be capital R, lowercase r. However, in Mendelian, the dominant, which is the capital R or blue flower, will be the one that expressed. In incomplete dominance or non-Mendelian, the results would be a combination of the two since the capital R is not fully expressed. So the result would be green instead of blue.
But, Big Bro Sibs, what if we cross two green flowers? Well, if we cross two green flowers, there's a great possibility you will get one green flower, one yellow flower, and two green flowers. Oh, really? Are there more? Well, James, there is what we call co-dominance. Like the word co-teacher, co-assistant, they both have the prefix co, which means the alleles work together. But wait, what do you mean the alleles work together? Well, James, it means that it will not just show only one trait, but it shows both of the traits of the parents at the same time. Whoa! You mean if we breed a black horse and a white horse, we will get a zebra? Whoa, that's amazing! Stop that, James. Well, moving on, guys. An actual example for that is when you breed a black sheep and a white sheep, there's a great possibility it will produce a black spotted sheep. Big bro, I don't understand. Can you explain further? Oh, little brother, still don't understand? It's easy. It works like this. So, if we cross a black sheep, capital B, with a white sheep, capital W, in a Punnett square, we could see that all the offsprings are BW, which means they are both black and white. As you can see, this is the essence of codominance. Cute sheep, right, James? But, Big Bro Sibs, what's the difference between incomplete dominance and codominance? Well, James, the difference of the two is incomplete dominance shows a trait that is between the trait of its parents, while codominance shows both trait of its parents. It's clear now, James, right?
Meanwhile.
Hey guys, did you know that my brother James is a good artist? He drew this! Yeah, I'm a good artist. James, have you ever noticed that Angie is taller than Lynn? And Lynn is shorter than Joanne? Oh, you're right, big bro. Why is that so? Say, big bro. Well, James, if we talk about height, we don't only talk about a pair of alleles like capital A, or capital A, lowercase a. It is more likely capital A, capital B, capital B, capital C, or more genes. And did you know that your skin color works that way too? And James, that is called polygenic traits. Wait, big bro, does the prefix poly means many? Well, James, you're right. The word polygenic means many genes code one trait. But both your height and skin color can also change because of environmental factors like your nutrition when you're growing up, and just staying under the sun for too long can also change your skin color. But big bro, does that affect your genes? Well, James, that does not affect your genes. Genes came from the parents of your parents of the parents of the parents of the parents of your parents, also known as the ancestors of your parents. Really, brother? That's so amazing! Okay, one last thing, James. Just always remember, when solving a problem, you can't always assume that it's non-Mendelian unless you're given a clue. And that's it for the Plasmodium Brothers. This is Baby Brother Jay! And this is Big Brother Sibs, bringing to you non-Mendelian genetics.